Okay, supposing I had a square whose sides were length 2. Its area will be given as 2 times 2, which we can write using our shorthand notation as 2 squared. And a cube, its volume will be given as 2 times 2 times 2, which is equal to 2 cubed. Okay, let's number these two expressions, 1 and 2. Let's multiply them together. 1 multiplied by 2. And that equals. Let's do it in 2's first. This is 2 times 2. That's expression 1 effectively, multiplied by 2 times 2 times 2. That's expression 2. You won't be surprised to find that can be written as 2 to the power 5. So instead of that great long line of 2's on the left-hand side of the equation, I can use our shorthand. And this is what we get. We get 2 squared multiplied by 2 cubed equals our answer of 2 to the 5th. So what expression links 2, 3 and 5 in this power line? Here's the power line. Well, it's simply 2 plus 3 equals 5. So we've got a rule for multiplication. Provided that base number is the same, you simply add the powers if you multiply two of those shorthand expressions together. Right, let's try a bit of division. Let's take our 2 to the power 5 and divide it by 2 to the power 3. On this side of the equal sign, I'll do the calculation in 2's. Do it the longhand way. So this is 2 times 2 times 2 times 2 times 2. And we're dividing it by 2 times 2 times 2. Right, let's do some cancelling. That first 2 cancels with the bottom 2. That 2 cancels with that 2. That 2 cancels with that 2. And let's put little ones here to remind ourselves that we've not just crossed the numbers out, they've cancelled down to 1. Okay, what are we left with? Still working backwards. We've got 2 times 2 on the top, which is just 2 squared. And that's now divided by 1. There are no 2's on the bottom, they've all cancelled down to 1. So that answer is 2 squared. Now look to the right of the equal sign. 2 to the 5th divided by 2 to the power 3. Well, that's going to have to equal 2 to the power 2. But by subtraction, if we subtract 3 from 5, we'll get 2 to the power 2. So this is equal to 2 to the power 5 minus 3, which is equal to 2 to the power 2. So we've got a subtraction rule. In this case, it was 5 minus 3 is equal to 2. Let's turn this upside down and see what happens. Okay, so I've got 3 2's on the top, 2 times 2 times 2, and I'm dividing that by 5 of them. What we're doing is 2 to the power 3 and dividing it by 2 to the power 5. Well, again, on the left-hand side of that equal sign, let's do some cancelling. Yet again, that first 2 will go with that first 2 on the bottom, that next one will go with that one, and that one will go with that one. Again, let's cancel them down to 1. Now, what are we left with? Well, on the top, we've just got 1, and the bottom, we've got 2 squared. Not surprisingly, really, if you compare that with the line above, we've just turned everything upside down. So by the rule we've worked out already, that subtraction rule for powers when we divide, this must be 2 to the power 3 minus 5. And that equals 2 to the power minus 2, or negative 2. So let's bring those two bookends of the expression that I've just written together, this one here. We've got the result that 1 over 2 squared is equal to 2 to the minus 2. Now, this is a very important result. It's very often misunderstood, and it's a mark loser. if you forget it or if you don't understand it. Negative powers are nothing to do with negative numbers. They just mean you've got a very small number. What is 1 over 2 squared? Well, it's simply a quarter. So let's write out the general form of what we've discovered. I'm going to use x instead of the 2, and I'm going to use m and n for our power numbers. X to the power m multiplied by x to the power n is equal to x to the power m plus n. Okay, now let's divide those two things together. X to the power m divided by x to the power n is equal, by the subtraction rule, x to the power m minus n. Now the negative powers. 1 over x to the power m is equal to x to the power minus m. So these three results are well worth remembering and understanding.